today's session is all about trying to solve performance issues or performance bottlenecks with OpenTelemetry. So we will focus on both what is OpenTelemetry, how it works, and also how we can utilize OpenTelemetry in order to actually detect and solve performance bottlenecks. So let's just get into it. So if we're talking about performance issues are usually tend to be hard. There are those who are very straightforward and easy and simple to fix. But if you look on the overall time that the developer is spending on identifying, understanding a performance issue, and fixing the performance issue, it's a time-consuming task. And it's a task that is very important because it's affecting our users, right? At the end of the day, we have our end users, and our end user suffer when our application isn't performing as we expect it to. Also, truth to be said, we kind of like as developers to fix performance issue. Usually those are the juicy and interesting ones. But if we're trying to set our goal, or our goal is to fix it fast, right? We want those issues to be solved as soon as possible. And usually those issues tend to have, in order to solve them, you usually need to have a lot of information. You need a lot of data in order to understand what is the issue and to fix it. So I'm going to show you a few performance issues today, and I'm going to start and try to explain what are the tools that we have today in the toolbox to work with performance issues. So let's start by some incident that we're having that could be related to a performance issue. So in the diagram that you see in front of you, you have a front end communicating with the coolest service ever that is communicating with MySQL. If you have an incident, that means that you have an alert. If you have an alert, that means that you have some kind of telemetry data that is producing all the time what is happening in your system. And with that, you can know if the system is behaving as expected or not. So in this instance, we can see here that the MySQL is saying, I need help, I have high CPU. And we all know that if you have high CPU, potentially you are going to have some problems in your system, most likely resulting in performance issues. And you could trigger based on that some alert. You can say, okay, I have this metric. I expect this metric to be not too high. 100% means something isn't working as expected. So I'm triggering an alert. Try to think of your system that you're managing today. If I were tell you, I would tell you that, hey, your database is having 100% CPU. What is the next step that you're going to do? So you know what component isn't working or it's having this issue, but you don't necessarily know what is the cause, right? You have a lot of investigation to do in order to really pinpoint what the issue is. So metrics are a great tool to kind of let you know, hey, this is the component that is currently having issues. So this is one type of alert that you can get notified that you have some issue. The other type would be from the service itself, from the application itself. We are writing logs, and logs, they are going to help us to know that we may have some issues. And if you think about logs, when you're getting alerts based on logs, now you know which component, but you also know which line of code. So I know a specific line of code. I may also have a call stack, meaning that a stack trace, meaning that I'll be able to know which path of code the application executed in order to reach this error. So I have much more information to handle this situation, but it's a very detail in a big system, right? If I have a lot of code base, if I have a lot of services, if the transaction is complex, it's going to be very specific details throughout a very large story. So this is the two things that you are probably running today. So I'm assuming that you're working with logs and metrics to some extent, but I am going to argue that while logs and metrics are super important, they are not enough, especially when you're looking at today's application, where today's application, they are way more distributed and more cloud native. So let me kind of show you how those incidents will look in a distributed system. So we still have databases, we still have the coolest service ever. However, we have, and we still have the same errors and the same metrics. But when talking about distributed system, we're talking about more than one service. So I have two services. I have service A and I have service B. Now, if I'll know that the MySQL is saying, hey, I have high CPU, it doesn't say anything about which component is currently suffering, whether it's service A, B, or the coolest service ever. Same goes with logs. The fact that I know that the coolest service ever is unable to route to the database, does it affect only the coolest service ever, or service A, or service B, or both, right? I can't know that just from logs. As I said, log is a single event in a very, very big story. So if I were to tell you another clue, hey, please take into consideration that service A is still functioning well. However, service B is not functioning well. That's going to give you a very big clue. And as we said at the beginning of the talk, we are interested in fixing problems fast, right? So the more details I'll be able to give you, the faster that you resolve this. So if I'm the developer trying to fix it, I'll probably look how the communication between service B and the coolest service ever is done. And I try to figure out, okay, what could cause the database to have a high CPU. In many cases, in distributed systems, people choose to not communicate directly between service to service because it could result in data loss. And then we introduce some queues, some Kafka mechanism, PubSub, SQS, RabbitMQ, any type of a solution where the two services are not communicating with one another. And this is creating a far more complex situation, because now, if you would look at the code and you try to understand if service A is communicating with the coolest service ever and how, it would be harder for you, because you will see that service A is producing some message to a queue, and service B is producing some message, and the coolest service ever is consuming it. But how will I know which message is belong to which service? So by introducing async communication and async messaging, we are kind of making the problem even more complex, making metrics and logs even less good at this particular situation. So what I would like to argue is that logs are too low level and metrics are too high level when we're talking about multiple services. We kind of broke the system down, this monolithic approach to services approach, but we kind of lost in this way our ability to monitor it well. And this is where I would like to introduce you to traces, or distributed traces. So distributed traces, I'm going to argue that this is the solution that you're looking for. This is what's going to help you to pinpoint those performance bottlenecks. So let me introduce you to a trace. In front of you, you can see Jaeger UI. That's a very common open source that displays traces. And you can see here in front of you that you have two portions of the screen. You have the left side, this tree view, and you have the right side, which is a timeline view. I'll try to explain you each part of them, what it does, what it means, and we will try to figure out from that how it's going to help us with performance. So in this tree view, what you can see in each row the part of the trace that happened. You can see here that the order service got an API call to a purchase order. Then the order service sent an API call to the user service to verify the user. Then the other service sent an API call to update stock to the stock service. It performed some DB query and then some additional DB queries. So you could argue that this is kind of logs, right? I have an event of what happened, but this is not just a log, because logs, it's individual logs that are not correlated to one another, and they don't have a child-parent relationship, as you can see here. So now I know what happened, but I also know why it happened. So I know that the user service was called because the other service called it because it got an API call from the purchase order. The same goes to this DB query. I know that it would perform, but I can see all the way to the root of what caused it. And it's important to remember that we have a parent-child relation between all of those spans. Each row is referred to as spans. I'll explain in a second why. In the right portion of the screen, you can see a performance view, timeline, how long each span took. And you can learn two things from it. You can learn how long each span took, but you can also learn if things happen in parallel or in sequence. You can see that the user service first ended, only then the stock service was called. Now, the reason each one of them is called a span and not an event like logs, because an event happens in a particular time, and a span is spanning over time, right? This span took 15 milliseconds. So it started here and it spanned over time, therefore the term span. So this is how a trace looks like, and this is the structure behind it. And we need to remember that because we are going to look into how OpenTelemetry is able to collect this data and then to visualize it. So when I'm looking at distributed system monitoring and of course performance, I'm looking at three main telemetry data in order to fix it. I think you need to have the logs. That's going to tell you the application story. We are all using log. That's a great tool. We need the metrics because we want to know whether the application is behaving within the expected boundaries. So I need to have some numbers telling whether it's good numbers or not. And we need to have traces because I want to understand why things happen, not only what happened, but also why they happened. So I've talked quite a lot on monitoring and performance in fixing and understanding, but I didn't talk about OpenTelemetry. So now let's talk a bit about the OpenTelemetry. So OpenTelemetry is an open source project by CNCF. CNCF is a cloud native computing foundation. It's responsible of dozens of projects. Among them, you would find Kubernetes, Prometheus, a lot of great projects. OpenTelemetry is a very active project. In fact, it's the second most active project within CNCF, only second to Kubernetes. So this open source project is actually is composed out of a few layers. So the first layer is the specification layer. OpenTelemetry is responsible of collecting telemetry data. We want to have this vendor-neutral, standard way to collect all your monitoring data, all of your telemetry data. So when you want to be a standard in the industry, you need to create a specification. So at its core, it's simply specification, how to collect and how to send and how to data structure all the different telemetry data. The second thing, now that you have the specification and everybody is starting to be aligned with the specification, now we need to bring it into life. To bring it into life means that we need to actually collect this data. And this is done by implementing a library, a package, an SDK within your code. So you will have implementation in each programming language. You have about 12 different implementation today. And you take this SDK, you implement it within your service, and then your service is starting to produce telemetry data. Once this data is starting to be produced, we need to have a backend, and we ingest all the telemetry data into this backend. We ingest it, we manipulate it, and then we can send it out. Sending it out could be sent to some database, could be sent to some vendors, could be sent to an open source like Jaeger that we saw earlier. And this is the three main components. OpenTelemetry is not part of visualizing your data, is not part of analyzing it, it's just part of generating it, ingesting it, and then shipping it to its end destination. So why OpenTelemetry is so trending and why OpenTelemetry is becoming kind of the standard way to collect telemetry data. So I think there are three main reasons. The first one is that at the first time, we have a single SDK, a single project that is responsible for collecting all the telemetry data that you will need. Everybody speaks about trace logs and metrics because that's what the project currently have, but the plan is to have even more. So the next one is going to be code profiling. So if you ever ran code profiling with some third-party tool or some open source, OpenTelemetry is going to offer it for you as well. So we're going to have more and more telemetry data in this project. And the second thing that makes OpenTelemetry, I think, the most interesting is that it's vendor agnostic. OpenTelemetry is completely open source. It's under a foundation, not under a specific company. And everybody is starting to align on that, meaning that to you as the end user, once you implement OpenTelemetry, then migrating from vendor to vendor, it's starting to be way easier. And if you have some vendor that you really like their tracing solution, you can send the traces to them, the log to another vendor, and the metric to a third vendor. So everything it's in your hand, and you can do things how you see fit. This is again giving the community a lot of power by having a single SDK that is going to be responsible on everything that you need in order to monitor your application. So this is the theory part, but I think most of us probably, or all of us, are technical people, and we want to see how things really work. So I'm going to show you three different things today. So the first thing is going to be kind of the OpenTelemetry stack. So OpenTelemetry has a few layers to it, so a quick visualization of that. Then I'm going to deep dive into the OpenTelemetry SDK, and we'll see how it's able to create traces. There is a bit of magic happening there, and it's interesting to understand how it works. And lastly, I'm going to show you a demo where we have an application with some performance issues. Some of them are more interesting, some of them are more complex, and we will be able to see how traces and OpenTelemetry in general can help us with that. So let's go to the OpenTelemetry stack. So this is the diagram that you need to think of when you're talking about OpenTelemetry. At the top, you can see your services. Those are already implemented probably, and you need to introduce them to the OpenTelemetry SDK. The OpenTelemetry SDK, again, a library package that you import to your code, you add it. Most languages, it's kind of easy integration, one-liner integration. You can use the OpenTelemetry native SDK. You can use a vendor SDK. That's entirely up to you. And then once you implemented that, data is going to start to be produced to an OpenTelemetry collector. This collector can run it your backend or a vendor backend. Again, your decision to take. The OpenTelemetry collector is going to ingest the data and then ship it to a database or to a vendor or to an open source. So those are the components that you need to have in order to run the OpenTelemetry stack. So if you remember a few slides earlier, I showed you a visualization of a trace, and I told you that we need to have a parent-child relation in order to visualize a trace. So how the SDK is able to do that? Let's take a look. So here we have two services, service A, service B. Each of them already implemented the OpenTelemetry SDK. And we also have a database that we communicate with. We already deployed the OpenTelemetry collector. So we're good to go to try to figure out how things are happening. So if I'm looking at this visualization, I would expect to see three spans. Service A is sending an API call to service B. Service B got the API call, and the database is the database query is the last span. So when service A is going to send an API call to service B, it needs to tell him, service B, I am the service that called you. We are all part of the same trace. Each trace has its own trace ID. Each span has its own span ID. And we need to make sure that all of them are using the same trace ID. So when service A is going to send an API call, it's going to inject into the HTTP headers the OpenTelemetry context, the trace ID, the span ID, and other flags if required. So the service A is creating a span and is saying, hey, I sent an API call to service B. The trace ID is 1, span ID is 55, and there is no parent. This is the root span. This is the beginning of the trace. This data is being injected as an HTTP header, and when service B is getting the request, then service B is reporting, hey, I got an API call from service B, from service A. It's the same trace ID. I took it from the headers, so this is the same trace ID. It's a new span ID, 66, but the parent is 55. And this is how OpenTelemetry is able to construct this this trace and this data structure. The same goes for the DB call, the same trace ID, new span ID, and the parent is the previous span. That's what allowing OpenTelemetry to create traces. That's what allows to visualize a trace at the end. So now that we know and understand OpenTelemetry and we know how it works, I want to show you an application that has a few performance problems, and we will try to kind of look at them, maybe even without looking at the code at all. Just by looking at the traces, can we understand what the performance issues are? So let's dive into that. So in front of you, you have some application. We have a few features here, and we have few different use cases. Let's start with a very simple and trivial use case. I'll start with use case number 2. So you can see here that we are loading a page. It took some time, few seconds, and eventually we were able to show some data in the UI. As a user, this is an experience that I wouldn't want to have. I'm referring to the loading experience, not the fact that I just threw JSON in the UI. That's another problem, but this is a demo. That's not that they're going to complain about. So now what I want to do is I want to find this trace. I want to find the trace that relates to here. So let me go and find a trace. So you can see here that we have a trace. It took 3.1 seconds. It also has the name /user/token/slow, which usually in your system, that's not going to be the name. But if we look at this trace, let's see what we can understand. So first of all, we know that we have an HTTP client. Mozilla called us. It called the user service, and the user service then called the MongoDB. So I have the whole story. I can understand everything that happened at the high level right here. Looking at the timeline, we can see something that is also making it very straightforward, right? It's very easy to understand that whatever spans you look at, they all took roughly the same, right? This took 3 seconds, and they all took kind of the same. So if I need to understand who to blame in this story, I know that's that the database fault, right? If the query of the database took almost 3 seconds, that's understood that the API call would take the same. If we click on this query, now we can see all kind of interesting things like all the raw data. So I have access to all the raw data that OpenTelemetry collected. If anything is interesting in particular, I can see here the request. And of course, it is a demo, so it's going to be maybe quite obvious. So if I'll click the conditions here, you can see that the query itself ran a sleep statement. So when I ran this code, I actually asked the application to the database to sleep for 3 seconds. So usually in real application, that wouldn't be the case, but you would find here some clues, right? You would find a query that is way too complex. You would find fields that are not indexed properly. You would find that you queried for, I don't know, 10,000 items, but you return only 10. You started to get a clue of what the problem is and where to look for the problem. So it was easy for us to pinpoint where the problem was, and it was easy for us to start and deep dive into it. Okay, now let's take a look at another issue that may be even more complex. So if you take a look here, we have use case number 1. Same thing, we have this loading mechanism. You can see here that we have title and we have the translation. Here we're talking about Spanish title. And we get report that this issue is even getting worse for larger account. You can see here that we have 3 rows. Let's go to the search and let's search for a developer, and maybe search also for Kubernetes, I don't know. So we know that our customer complained that when the account gets larger and it has more things in it, the problem getting even more complex. So let's click that again and see if they are correct. So previously it took a few seconds, and now you can clearly see that it's taking a lot of time. So we were able to reproduce this this issue. Maybe we reproduce this issue even too good. So let's start to have a look at what's really happening here. So I didn't open the inspect. So let's look at what API call is being called here. So that's the wrong use case. So you can see here that we're calling /translate. That's the issue that we're having. I really hope that it will work because it's taking way too long. So now that we know the API endpoint, we can see the API that is being called. We now need to go back and find the relevant trace that is causing this issue to happen. So let's search on that. Let me see in the code, maybe we have some issue. Oh, yeah, of course we have an issue, but never mind, we will be able to work with that. So you can see here that we call the article translate. So article translate. And looking at the article translate, we can see that it's really taking a long time. So clicking on that, we can now see the whole story. And we can see here that we have even more than one service. We have multiple services. And if we're trying to figure out what's happening here, we can go to the timeline. And in the timeline, you can kind of see a pattern that is very familiar to N+1 query. So you can see here, let's look right here. You can see that we have an HTTP call that is happening 3 times. Each one of them is taking quite some time, almost a second for each API call. And when you're looking at the timeline, you can see that each one of them is happening not in parallel, but rather in a sequence, meaning that the user is going to wait a lot of time in order to get a response. Now, as I said, people are complaining that as the account gets bigger, it has even the problem is getting worse. And that is because when you have an N+1 query, here we have 3, but if you have 30, the problem just is getting worse by 10 times. So by looking at this kind of a visualization, it's making it very, very easy to solve. Try to think of that if you would need to solve it from metrics or logs. It would be very hard to understand what's happening here. And if you're looking at a trace, it kind of pops out and straightforward to really understand what's happening here. So this is a pattern that we see a lot, an N+ query and N+1 query. And that's the second use case that I wanted to show you. The third and last one that I'll show you today would be the use case. So you kind of saw the same pattern, right? We click something, it has the spinner, and then we display it. It didn't took a lot of time, but I do want to show you something interesting that we see a lot happening in the system. So we have an API call taking about a second. So that's too long for an API call, but that's not too long crazy. So if I'll click on that, now you can see something very interesting at the time. So we see an API call, right? We can see an API call to this API weather map.org. We can see that we had two calls. They are not happening in sequence. They are happening in parallel. And then we have a gap. So, and after the gap, we have a call to the database. So if I'll ask the question, what can I learn from this trace? I can learn, or what can I ask from this trace? There are two questions that I want to ask. The first one is, can those two API, can they be parallel, right? Because from here, we can still clearly see that they're happening in sequence, but if they can happen in parallel, that would improve by a lot. You can do that only if the response of the request is independent between those two. If they are dependent to one another, then they has to be in sequence. And the second question is, what happened here, right? We have this time, almost 300 milliseconds, that we don't know what happened. So let's answer it question by question. The first question is, does the request here is dependent or independent? So that we can look at just at the code and figure out whether it's dependent or independent, and then what happened in this situation. So let's jump to the code. That's going to be a very simple, straightforward code. So this is the API call, the /get API call. You can see the first API call that we had. That's great. And we can see that we got the coordinate. From the coordinate, we took those lat and long, and we are using those. So those can be in parallel. Then we are saving to the database, which is exactly what we've seen those two scenarios. And we have in the middle a really long computation. So if I'm looking at the code, I can understand what's happening. Again, this is a demo, so the code is in one place, not spread throughout many files, and the name suggests that this is a long computation, but in real life, this could be very complex to understand. And by having kind of a dead zone within my trace, I am not able to understand what's happening. So let me show you a quick thing that we can do. What we can do is we can create a span. If we were to wrap this span with an annotation saying, I want to report it into the trace, and now let's go back to our demo application and rerun the use case and search again for the /get. Let's the route get, let's look for it. So now you can see I had 5 span, now I have 6 span. And if I'll look here, now the story is complete. Now I know that the weather service had a long running operation. I didn't write any metadata. I could add some, and I also have the stack trace to know exactly where it happened. And now if the next developer would look at that, it would make more sense to why this happened and whether it makes sense that this operation took 330 milliseconds. Maybe that's wrong by itself, but now I can know. So we saw kind of three different use cases. One relates to database configuration, query, something of that sort, which is very, very common. Then we saw an N+1 query where we are just having an operation that is happening over and over again, and that causes it to just take a lot of time, and usually those things could be optimized quite easily. And lastly, OpenTelemetry is looking at the communication between services, between the service to a data source, the service to a third party, but it's not good when it's not good automatically to instrument your code, your interesting functions. So when you have this blind spot in your trace, usually it makes sense to add some annotation to create a new span in order to make sure that the trace is complete and it speaks by itself. So that's everything I wanted to share with you. So 1 second before I am opening the conversation to any question that you might have. We created an OpenTelemetry Bootcamp. The OpenTelemetry Bootcamp is a 6 hours course, free course about OpenTelemetry divided into 6 different episodes, starting from the basics and building it up to production grade deployment. So if you're interested in that, please go ahead and visit the Bootcamp. I think if you're interested in OpenTelemetry, that is a great resource to start learning it. And if you have any questions, I would be more than happy to answer.
Yeah, so first of all, thank you, Michael, for that. We do have one question. Is there a way to trace individual local calls without wrapping them?
Yeah, so when you say local calls, if you mean function calls, so usually you do need to wrap them. You do need to let OpenTelemetry know that you are interested in instrumenting this specific call. If you're talking about call between services, that is like HTTP or over-the-wire messages. Those are auto-instrumented and you get it out of the box.
Okay, thank you. Any additional questions, anyone? In the meantime, I'm sharing the poll results. Let's see how it looks like. Now you can access it yourself and see by yourself. If there are any additional questions, so thank you for joining us today. As mentioned, you will be able to find this recording and others on our YouTube channel. Follow us on Twitter, LinkedIn, whatever you choose, in order to see like next events and so on. In the meantime, we did get another question, so let's try to push this one. Michael, have you ever run into performance problems with auto instrumentation? Does it add any overhead, latency, and so on?
Yeah, so there are two aspects to it. So when you add an auto instrumentation, you do add overhead. We can't avoid that. But I think the overhead is not significant, and it definitely worth the value that you're getting. With our customers, even with high intense environment with a lot of workload, we usually see an increase of up to 2 milliseconds in latency. So I think it's definitely worth the value that you're getting out of OpenTelemetry.
Cool. Yeah. So folks, don't worry about that. If you want to try and use OpenTelemetry. Yeah. So again, you can find all the content online. Feel free to reach out to us over any social media. We also have a Slack channel within the CNCF Slack. It's called the OpenTelemetry Bootcamp. You can join this Slack channel as well if you have any observability OpenTelemetry questions. in order to join it, you first need to join the CNCF Slack. You can just Google CNCF Slack, and then look for our channel. Yeah, and that's it for today. Thank you everyone for joining us.
I did so ask one question about communicating with the MQ, with I guess RabbitMQ.
Yeah, I missed it.
Yeah, so this could work depending on the language that you're using. We actually contributed the RabbitMQ instrumentation in Node.js. So there is support of that. RabbitMQ or messaging queue in general has their own space to like HTTP headers. There are headers and metadata to message queues. So yeah, that could work and should work.
Yeah, even I'll share a quick blog about it here that we wrote recently. This is specifically for Node.js, but yeah, it might be helpful. Okay, cool. Thank you, everyone. Have a nice rest of your day, or good night, or wherever you are in the world.
Thank you very much.